In this lesson, we're going to take a look at output formatting. Now, the default for the precision outputting numerical values for floating point types is 6 significant figures. Can you change that? You certainly can. Also, the default for outputting numerical values is to give it, as far as the width of the field of that output is concerned, give it as much space as is necessary and no more. You've experienced all of this all along. Now we're going to show you how to change some of these things. To begin with, let's look at precision. And first of all, you're going to need to include the system file iomanip to allow you to make these format changes. Let's declare grade to be of type float and assign it the value of 86.1263, and then there's an F there. What's that all about? Well, internally, a constant literal like this, 86.1263, is stored as a double. If you then assign that to a float type variable, then there can possibly be some truncation issues and round-off error incurred. If you want to avoid that, then put that F at the end, and that tells the compiler you want it to be a float and store it as a float, and the precision will be exact. The F really isn't necessary. It's very rare that you're going to run into a problem with this, but I thought I would show it to you. If I say cout.precision for, again what I'm doing, since I'm using the dot operator, is I'm calling a member function of the class of objects to which cout belongs. I keep saying these words because I'm trying to get you used to the idea of object-oriented programming. This will all become clear when I start talking about classes and member functions. In any case, what you're doing is you're setting the precision to be 4 significant figures. Now that is not 4 places after a decimal. It's 4 significant figures. And what you're going to do is you're going to set the output to be 4 significant figures, and you'll get the 8, 6, and 1, 2, and because this is bigger than 5, it's going to round it off. So the output here is going to be 86.13. 4 significant figures. Now, does it change the value of that variable grade? And the answer is no. It's still 86.1263. This is only changing what you see in output. And sure enough, there it is. Let's take a look at another example. I've got grade 1 is 86.1263, grade 2 93.1311. I'm going to set the precision to 4. I'm going to output grade 1 and then later output grade 2. What do you think the results are? Well, as it turns out, setting the precision will hold for the remainder of the program until you change it back. And incidentally, if you want to change it back to the default, you can do this, cout.precision with empty parentheses, and that means you get 6 significant figures. It's a defaulted argument. And sure enough, you have 86.13, 93.13. Okay, let's take a look at the width of output. I can change the width of output with the function, the member function, width. Here I've set it to be 10. Now the trick you have to understand is setting the width will hold only for the very next output. So I'm going to output grade 1 and then output grade 2, and we'll see what happens. Now notice with both of these numbers, you need to count the number of places. There's 1, 2, 3 for the decimal, 4, 5, 6, 7. Okay, so there's 7 places or 7 spots. Okay, what that means is we can predict if I make a width of 10 for the first output, the second output is going to default to the standard way of outputting. So I'm going to have 3 blank spaces and then the 86.1243, and then I'll return to the standard of giving exactly the width that's necessary. So there are 3 blank spots here. Everything will be right justified also as a default. Now there are iOS flags. So you can have statements such as cout.setf, and then in parentheses iOS, : and then whatever the flag is. You can also have cout.unsetf, and that will undo whatever it is that you have done. Okay, let's take a look at the different flags. There is scientific, and that's going to output in scientific notation, the E notation. Fixed, which gives you standard notation output. Right is right justified in the output field. Left is left justified in the output field. Internal, that puts spaces between the negative or positive sign and whatever the output is. Show pos will show the positive sign. Show point will show the decimal point with trailing zeros. And skip WS will skip white space in the output. So let's take a look at an example. I've got a double mole equal to 602200, and then a lot of zeros. Grade, which is 97.153. I'm going to set the output to scientific, output the mole, unset the scientific, and then output grade. So we should get the big number in scientific notation and the smaller number in regular notation. And sure enough, there we have it. Okay, another example. Money is 1441.3531. There are times when you want to force an exact number of decimal places. For instance, when you're outputting monetary values. Okay, for instance, if you have a monetary value of 3.5, you want to output it not as 3.5, but 3.50. That's what looks good. $3.50, not just 3.5. So how do you force that? Turn on fixed, turn on show point, set the precision to 2. So when these two things are on, then precision refers to the number of decimal places. And so I would get that as an output. Manipulators are a little bit different from the member functions. There are 5 of them here. Here's a familiar friend, inline. We know what that does. Set W does exactly what the width function will do. And just like the width function, it will apply only to the very next output. Only. Set precision does the same thing as precision, but it will last for the remainder of the program. Flush will flush the output buffer, and set fill will put this character value in all empty spaces of the field of output. Set W sets the width, set precision sets the precision, inline puts the cursor at the end, flush flushes the buffer, and set fill fills the empty spaces. Again, let's take a look at an example. Grade 1 is, grade 2 is, we're going to set the precision to be 4, output grade 1 and output grade 2. What are we going to get? We're going to get 86.12 and 93.13. Exactly. And it doesn't matter whether we set the precision with the manipulator or the member function precision. We will use the manipulator to set the width of output. Here I've got grade 1, 2, and 3. I'm going to output grade 1. Then I'm going to set the width to 10, output grade 2. Then I'll set fill to star, set the width to 10, and output 3. Now let's see what it looks like. Okay, 86.1243 is going to be centered in the width of field necessary. The second one will have 3 blank spaces because it's in a field of 10. The last one will also have 3 spaces, but they're going to be filled with stars because I turned on set fill. And that's the end of this session. You can use all of these functions and manipulators to modify the look of your output. Usually this is done for tables, done in loops. Remember that the width setting functionality only holds for the very next thing that is output. And that makes sense when you start thinking about how you might build a table of output.